am Tom Spangler. I'm a member of the NX product marketing team with Siemens. Been with the company for a little over 15 years now, in a variety of roles. Before that, I worked in the automotive industry, both on the supplier and the OEM side, as a designer, data management, and lots of other associated roles with that. So let's go ahead and get started. And we're going to talk about how NX fits into Siemens Accelerator. So as you probably know, Accelerator is an integrated portfolio of software, services, and an application development platform that kind of speeds the whole digital transformation, and it unlocks a powerful network cycle effect. NX is the mechanical design portion of Siemens Accelerator. And we feel that it delivers best-in-class productivity for engineering and helps you expand the use of the digital twin across the whole engineering process. It's seamlessly integrated into the whole Siemens Accelerator portfolio, and it does it in a flexible way. So we're going to start off by sharing a little bit of commentary from the market. This is a comment from earlier this year from SimData. And this theme of innovation is something I'm going to keep coming back to in my brief presentation here. It's showing how we're continuing to innovate in this space in the service of helping our customers. So this is a quick roadmap of kind of where we've been and where we're going in 2023. We have a major NX release every 6 months, every June and December. And then we have continuous releases and monthly updates in between. So NX is always up to date with the latest enhancements, new features, bug fixes, and everything else. We launched NX 2306 in June, and we're ramping up for our NX 2312 launch here in December. As a matter of fact, we're in the middle of our early access program right now in Costa Mesa, California. That's currently happening. We're also finding ways to innovate and use machine learning and artificial intelligence to improve our productivity. NX was actually shortlisted for corporate innovation in the world's only independently judged AI awards, which are the Alconics. That was a couple years ago. And NX is the only CAD system with an adaptive AI-based user interface. And that user interface adapts and personalizes user interactions, so it makes them easier and faster. It provides a personalized expert assistant that collects data while you interact with it. So it provides the best choice or set of choices based on what you've been doing and what you're about to do. And it predicts with about a 95% accuracy what you're going to need next. It also tailors the user interface to show different levels of complexity depending on the expertise of the user, and that helps to lead to productivity gains of about 30%. We also have a smart sketcher that anticipates what you want to modify and the logical relationships that are needed to make the whole process faster. We're only pushing harder in this area, actually, with more AI-enabled applications and proactive agents that are going to make the whole process faster and more efficient. Visualization helps to prove the digital twin. It gives you an accurate representation of what your design is going to look like in the real world. So that means better designs the first time and fewer physical prototypes. Siemens Visual Material is our take on a standard physically based visual material that enables consistent sharing of visual representations across all of the current and future Siemens applications. And going forward, we're going to bring this high quality visual representation to all the platforms. So not just NX and Team Center, but in the browser and even in virtual reality, as you can see in this video here. So as products become more complex, the need for strong collaboration is only increasing. Electric cars, for example, combine mechanical, electrical, electronic, software, and more with complex cooling and chemistry requirements. So we've progressed from basic check-in, check-out functionality to the point where we currently support real-time change monitoring and notification. In future releases, we're going to support true collaborative co-design, where multiple users will have access to the same parts at the same time. That can include different disciplines as well, so the electrical and mechanical designers can collaborate in real time. We're also leveraging cloud and SaaS to help designers collaborate wherever they're physically located. As we see it, one of the biggest advantages of NX is flexibility. And that's reflected in our open philosophy that enables you to use the best tools for the job, no matter what, and our excellent multi-CAD capabilities as well. That flexibility also applies to how NX is deployed. You can deploy it on premises where everything is on site and you manage the setup, updates, and everything. Or you can use our cloud-based option, NXX, where we manage the licensing, configuration, and updates for you. Either way, you're getting the same user experience and the same data format. It's all one NX delivered to meet your needs. We're also constantly developing new applications using the NX data model. One of the ways we deliver them is through flexible value-based licensing, or tokens. Tools like electrical and mechanical routing, rendering, PMI, human modeling are all accessible from the token pool without having to explicitly buy those models or those add-on modules. That gives you a lot more flexibility than you need than before. You can only run what you need and when you need it, and you don't need to make separate purchases. And you have access to new products from day one. We've increased the applications available in the token pool by about 117% in the last 3 years. Now there's over 100 products in there. So there's an idea in the market that there's not a lot of innovation to be had in the CAD space. People think that CAD is a commodity, and how much better can you make it? But we've had quite a few patents in the last few years, 25 of them in 2022 alone. So I think we're showing that there's always room for more innovation. Our competitors are not talking about this because they don't have the record to stand on that we do. We also delivered 519 customer enhancement requests in 2022. So this goes back to the continuous release idea of being able to have access to these enhancements right away. It shows that we are refusing to let our customers fall behind. So if you have a customer that's only a few releases behind, they're missing out on all these innovations, all these enhancements, all these fixes, and everything else. And it also shows that we're listening to them. So we've seen, again, our competitors are not necessarily listening to the customer as well as they could, and that was a major factor in our recent win with Hyundai Kia. So that's about it for me. I thank you for your time and attention.
Hello, everybody. Welcome to today's webinar. Today's webinar will be on model-based definition. I'll be your host, Bryan Fisher. I'm a senior NX application engineer with Prolim out of Cincinnati office. If you have not done so already, please go and like and share our YouTube channel. You can get a lot of information within that YouTube channel, including our past webinars. Let's go ahead and look at a quick bio of myself. I've been in the industry over 20 plus years, 15 plus years as a designer in the aircraft industry, and 5 plus years as a designer in the medical industry. I've been using NX this whole time. Additionally, you can see my education here. If we move on, we can go and start looking at what the agenda will be during this webinar. As you can see here, we'll look at what is model-based definition, MBD. We'll look at NX product manufacturing information, PMI. We'll do some validation, search and reporting. We'll do some PMI automation, and then we'll look into PMI authoring. So what is model-based definition? To look at model-based definition, let's first look at product and manufacturing information. Within NX, we're able to go and put non-geometric data and apply this to a 3D model. We can put dimensions, tolerances, GD&T, datums, and such. Now, model-based definition is taking that information a little bit farther and putting charts, materials, and such to it. If we look at model-based enterprise, this is actually where we're taking this information and we're using it downstream. So you may use it in NXCMM, NXCAM, maybe even in VisMockup, which allows you to go in and actually use VisMockup VSA, which you can go and take the tolerances and do stack ups. So there's a lot of things you can do with the model-based definition and the PMI. This is the whole tier of it here. For today, though, we're mostly going to be focusing on the product and manufacturing information, PMI. So for today's presentation, we're going to be using NX 2206. That is the latest release that was released in June of 2022. We'll be looking at the NX product manufacturing information, PMI. We'll start off by doing some dimensions. We'll do a basic dimension, some hole call out, put some tolerance to it. We'll then get into some annotation. We'll do a feature control frame, put some datums on it. And then we'll look at a couple little things for supplementary geometry, such as center lines and section views. Now we're back in NX. Let me go ahead and first show that I am using the latest and greatest. If I go help here and about, you can see I'm in 2306, which came out in June of 2023. And the first thing I do want to show here is that we now have a new tab over here on the left-hand side, just for model-based definition. So we'll be going in and utilizing this throughout the webinar here. And you'll see here, it is still done inside the standard views, but you don't go up here into your part navigator and go to your model views here. You actually have this new tab right here that allows you to go in and easily see the tree that you're creating when you're going in and creating these PMI. Okay, so we're going to be using the toolbar over here, like I just said, and we're going to start dimensioning this out like we would in drafting. However, we'll be doing this in a model view, so we'll be in 3D. So up here in my PMI tab, you'll notice that I have my dimensions here, which if you worked in NX drafting, you should be familiar with a lot of these commands. We then have our annotation for control, feature control frame, datum feature symbol, and so on. We have some tables that we can insert, some supplementary geometry, such as we can go in and actually add a section view to this. We can do some region, we can do center marks, we can do bolt circles and such. And then if we look here, we'll have our technical data that we'll be adding later on and some rules. And we have a query and advisory here. I'm going to go ahead and start dimensioning this. The first thing I'm going to do is hit my rapid. When I come in here and do my rapid dimensions, I'm going to come in and select my two faces. I want to select my faces because these are the important if you're using this downstream. So here, as you can see, very similar to NX drafting. The only difference here really is I can pick a different plane if I want to have it on a different plane. Additionally, I'll come in here, I'm going to add some tolerance to it. I'm going to go and also add a how it's placed. Now, if you want any of this to be standard, just like in drafting, you'll go into your customer preferences, defaults, and your preferences, and you may create a template file. But for today, I'm going to go ahead and utilize what I have here, and I'll show how you can inherit that from one dimension also to another. So I'm going to go ahead and place my dimension. You may notice that that dimension does not have trailing zeros. That's part of the preferences that you could add. So if I came in here and I went to my settings, I'm going to add the trailing zeros to my part here, and now I have my first dimension. If I rotate this, you'll see that this is a dimension that is in the 3D environment. My next thing I want to do is I want to add some feature control frames. So I'm going to add some GD&T to this. Now this has changed from the last version. So from 2007 to now, the version has changed a little bit. You will no longer have your annotation in here to go and put your true position, flatness, parallelism, and such. What you'll need to do first is you'll go into your leaders here, and you'll go get a flag, in this case, because I want to flag it to this. And I'm going to go and place my dimension. I mean my GD&T. You'll also notice, though, because I put it on that particular dimension, it's selecting two objects. I don't want both objects in this case. I just want the bottom face. So I'm going to go and select that. And I'm going to go ahead and rotate this. Let me go ahead and get that rotated properly. Oops, that's my bad. Sorry about that. Now we have it rotated, and I can see where I'm going to place my GD&T. I'm going to go and place my GD&T in this manner here. And I have not put any of the GD&T yet. All I did is placed where I want my GD&T. Then as soon as I do that, you will get a toolbar up here for feature control frame in general that allows you to go in and put your information. So I'm going to pull this down and put a flatness. I'm going to go and actually put 5 thou on this. At this time, if I did have any, if I wanted to maximum, or if I wanted to regardless of feature size or anything like that, I could add that. In this case, I am just putting a flatness, so I'm going to put 5 thou. If I had a datum reference, depending on what type of GD&T you're putting in there, you'd put your datum reference. So I have my information I want, and I have my face that I want. I'm going to go say OK. So now I have my GD&T, and I have a dimension. And if I look over here on my MVD Navigator, you'll notice in my standard view, if I go and let's make this a little bit larger, you'll see that my feature control frame is now here, my annotation, my linear dimensions. If I go to dependencies, it would tell me what is dependent on that. So you can see associated objects, my 2 faces in this case, and it lets me know that that's in the front. I'm going to continue on dimensioning this out, and I'm going to add some datums to it. So let's go ahead and look at my datums here. Here's my datum feature symbol. I'm going to go ahead and reset this, and I'm going to put datum A in here. So let's go ahead and put A. And I have my leaders here, so you have your different types of leaders that you can put in there. Once I have what I want here, I'm going to go ahead and select this particular feature control frame, and I'm going to go and place my dimension. I mean my datum, I'm sorry. So now I have my datum that's also under my annotation. If I double click on that, it automatically selects the bottom object to for me because it's going in and selecting my feature control frame. So now I have a dimension I've added, a GD&T I've added, and a datum. Next, I want to go in and maybe I want to dimension the hole there. So with that hole there, maybe I want to come in, and first thing I'm going to do is I'm going to go and center mark. I'm going to select my object. Notice I have different planes I could put that on, but in this case, I like where it's at. I'm going to say OK. Next, I'm going to come in and I'm going to get another dimension. So here I'm using my rapid dimension again. I select my center mark, select my face. And this time, when I go to place it, I'm actually going to say I want to inherit this other dimensions. And notice that it gives me the same tolerance, gives me the trailing zeros and everything else. However, maybe because I want to put some GD&T to this, maybe I want to true position that hole. I'm actually going to go in and say, I don't want the tolerance. I just want to put a basic dimension on it. Place my basic dimension, and now I have that hole started to be in dimension. Once I have all that information, I can continue on, and dimension this the rest of the way out. Let's go ahead and do that. I'll go ahead and put my other dimension here. Whoop, that's my bad. I select the wrong object. Let's go ahead and reselect my object here. And I'm going to go ahead and select this face here. Place my dimension. Let's go ahead and inherit this one, actually, this information, and place it. And now maybe I want to, put another dimension in for the size. Again, I'll go in and inherit my information. Now, again, if you have this set up in your preferences or your customer defaults, or if you have even a template file, start part or whatever you like to call it, you wouldn't have to keep on doing this. In this case, I'm out of the box. Now let's go ahead and I'm going to put another feature control frame. This time I'm going to put another flag on it. I like that. I'm going to go ahead and select this edge and pull it down. Once I have where I want to place it, again, you will get this toolbar up here. In this case, I want to have a true position. So I'm going to go ahead and do a true position. We're going to leave it at 5. I'm actually going to put a diameter on that. My primary datum is A, let's say. My secondary is B. And my third would be C. So now I have my true position there. Well, in this case, guess what? I did it wrong. I want to have that perpendicular, not a true position. So you can always come back and change that. I got ahead of myself there, actually, and tried to put true position on an edge. In this case, I wanted to do the hole like that, but that's all right. I went and quickly changed this. And once again, if I say select objects, you'll notice that it picks both faces. In this case, that's not what I want, so I'll go and deselect this one, and I'll go and place my perpendicular. So I have my perpendicular placed, and you can see here over in my tree, it continues to build in my tree. And if you want to at any time see where that is placed, you can go in there and you'll see the status. That status lets me know that there's PMI in that particular view. And as I showed earlier, the dependencies will show you more information. So the associated object and the model view, and also what is maybe stacked to that. We'll go ahead and continue on this. I'm going to go and make that a datum myself also. We'll go and make that datum B. So we'll say datum B. Actually reset that real quick and go datum B. Take my leader, select my object, place my datum B. So now we've gone in and we put some basic dimension. We put some dimensions over all sizes with some tolerances, some GD&T. And next, maybe we want to put dimensions for the hole there. So up here, we have hole and call thread out. Much like the draft inside, I'm going to go ahead and pick that. I have radial or linear. I'm going to go ahead and say linear. I mean on radial in this case. Pick my hole. And once again, I go and place it. And you may notice that may not look like you want it. So that again depends on your preferences or your customer defaults that you may have. Now I'm going to go and put that other GD&T for the feature control frame. In this case, it will be my true position that I tried to place earlier. And we'll go ahead and put that information in there. And you can quickly see if I select on that, I can always come back and quickly double click on it and change that information, such as what I did earlier. So now I have this pretty good and pretty detailed out, pretty decent. So we've gone in, we did our dimension with basic dimension. We did a hole call out, some annotation, feature control frame and datum feature. And then we did a supplementary geometry with our center line. Now what we may want to do next is, if we look at this, we have two holes here and they intersect each other. Maybe we want to have a section view. So if we come in here and say section view, notice this section view is very similar to what you would have if you were in model and if you ever done any section views in there. And here I can pick my different planes and such, display, cut, and plane and everything else, cap settings. I'm going to go ahead and rotate this. And I'm going to get it in the orientation I want, because this is going to be saved as a model view. I'm going to go ahead and OK this. And now if we look at our section view here, we got our section view. If I wanted to add cross section to it, we can go in and edit the edit section view here, or we go into the settings and display the cross hatching. Now, as I said, this is done in model view. So if I go back to my front, you'll notice that inside my front there, you have your dimensions, your GD&T and everything. At any time, if I wanted to move these, I could go and actually say, for example, let's say I want to put this in another view. I have the ability to navigate to the view. I have a display in views, display in all views. So I can move that to any view I want. Now that we talked about what model-based definition is, MBD, and we've also talked about product manufacturing information, PMI, we then went in, as I stated, and we showed how to dimension some basic dimensions. We showed a hole call out. We went in annotation, did some feature control frame with some GD&T, and then we put some datum features. Additionally, we showed some supplementary geometry with the section view along with the center lines. Moving on, we're going to start looking at search and report. So we're going to look at MBD query. We're going to look at a text base. So in this instance, you can go in and type in what you're searching for example, in the example I show on the screen here, datum feature, or you can go rule-based. You have certain rules that come out of the box, and then you can recreate a report from this. Once we do that, we'll go in and find some PMI associated to the geometry. This creates a temporary view that shows you what PMI is linked to which geometry. Then we'll go on and we'll use the advise. This is on the next slide here. I'll show you that when we get to it. and then we'll go to the compare, which is on slide 8. So now let's go ahead and jump back in NX and start going through some of these. Now that we're back in NX and I have my model up here, let's go ahead and look at the MBD query first. MBD query can be found over here in our resource bar on the left-hand side. The first one we have is text-based. So within text-based, I can put different information. For example, I can say datum, datum feature. If I say datum, you will see now that it brings up the information here and highlights it on the side. Additionally, we can go and create a report. When we go and create a report, we have different information in there. It tells us what face it's associated to and so on. And if we prefer to, we can actually export it out to a spreadsheet. When we go to export this out to a spreadsheet, it will put it in an Excel spreadsheet. Within that Excel spreadsheet, we have information that we can go and look at. Different columns, layers, rules, different things such as that. It gives us a date and label and so on. So this gives you a report that you can go and actually share with individuals. I'm going to go ahead and close this one. Give it a second to close the Excel. And the next one we're going to do is let's look at our rule base. So rule base, we have several different ones that we can look at. Find dimension, find datum, surface finish. These are all out of the box. So I'm going to go ahead and say find dimension. It's going to ask me which ones I want. Dimension value, I can actually put a value in there if I choose. So if I said 10, for example, that's only going to find the dimensions that are 10. So from here, I'm going to say OK. And you'll notice that it highlights my dimensions that are 10. You can create a report from there. You can also create a model view from there. So that gives you the ability to go in there and quickly do a query on your model. Next, we're going to go in and actually do a find PMI associated to geometry. First thing we want to do, though, is I'm going to go ahead and remove this report that we just did. And I'm going to come up and I'm going to go into my navigator here. And over here on the right-hand side, we have find PMI associated to geometry. From here, I can select. And let's just say, for example, I wanted to find PMI associated to this hole. I can create a query result view here if I like, and I can attach to PMI also. So let's go ahead and just say OK for this one. It tells me it creates a temporary display for me. And notice that it creates a temporary display and only shows the information for that particular geometry. Now you may ask about where's the dimension. Well, those dimensions are actually attached to this particular crosshair. So if we say find associate geometry again, and this time I pick the crosshair, you notice that it will find that. And again, that crosshair is associated to the hole, however. So that's a quick way that you can find what PMI is associated to which geometry. So the next portion of this, we're going to jump into what we call PMI Advisor. This check will actually go in and check your geometry for you and your PMI. For example, if you did not have a tolerance on a dimension, it will let you know that. If you're missing a datum reference, it would also let you know that. So let's go ahead and jump back in NX, and I'll go and run a quick one of these and show some of those examples. Okay, so we're back in NX here, and I want to run an advisory on this. So up here in the right-hand corner, up in my toolbar here, you'll notice we have this advise. Validates PMI using the current configuration rules. These rules are set by whatever rules you have for your customer default for that particular file. So for example, your GD&T is set to whatever ANSI standard and so on. So here I have my advise. I'm going to go ahead and select that. And once I run it, notice I get a couple errors here. Now I did these on purpose just to be able to show some of this. So if we look at our feature control frame here, a datum reference is required for this. So if I say show advisory check, it tells me exactly what's going on. It requires a primary datum reference. I did not add the datum reference to this. So because of that, it recognizes that that datum reference is not there and I must add it. If I look at my other one and I say a show advisory, it has a couple different ones. add geometry to this, or remove it if it's necessary. Another error it has is there is not a defined one for the third datum. So this will let you know exactly what is wrong with these particular features. Let's go ahead and fix those, and then once we fix those, we will go in and run this again. So let's go first one here. I'm going to double click it pretty quick here, and we're going to say, okay, we want this to be datum A, and apply that. Next one here is, notice there's no geometry to it, so I'm going to go and select this hole. Now, datum C is not there, and I have not put a datum C yet. If I came in and quickly just put a datum C, oh, I'm sorry, I hit the wrong one there. That's a datum that allows you to do your A, B, and C all at once. I meant to hit this datum feature symbol over here, and I'll show an example of that next. But right now, let's go ahead and put this in. And I'm just going to put it on that face. So now I have a datum. Now that's not necessarily the way I would place it, but this is just to show you that it will go through these checks and find these checks for you now. So I'm going to go ahead and advise again, rerun it, and notice I get no results now. That's because it recognizes that I have this set up properly. It may not be pretty like a drawing, but I do have a datum C that's associated to that face now. And I also went in and fixed the other GD&T. Now, I talked about just a second ago how I accidentally went and selected that additional one over here that says datums there. This creates your secondary, primary, and third, and you can do that quickly just by going like this. Select datum A. In this case, we had our bottom, datum B, and datum C. It will go in there and actually create them for you in that manner. I do not prefer that manner myself. I like to make it a little bit prettier than that and like to put it in the views. And I think that's partly because I'm an old draftsman and I had worked on the board for a very short time, but have done a lot of traditional drawings. Neither way is wrong. It's just a different manner of getting to it. Now, the next portion of this, we're actually going to go in and do an compare of two different revisions. I'm actually going to go ahead and close this one, and I have two models that I've already have that are going to be used for that, two different revs. There's been some slight changes between them, and we'll go ahead and actually go in there and show that. So within the PMI compare there, it will actually go through and look at your source part and your comparison part, and then go in and actually label the differences between the two. So here we are back in NX. As you can see, I have a model for Rev 1 and I have a model for Rev 2. And what we're going to do is we're going to act as if we're going in and we're going to look at these two. First thing I want to do is go into my PMI and I want to see what the two different changes are. And I'm going to go to my compare under the tools here. Compare PMI and model views between two different parts or revisions. As soon as I hit that, it's going to have my source part as my part that I currently have open. If I didn't have it open, I could also go and search for it if I needed to. And same with my comparison part. If I look at my comparison part right now, I'm going to go ahead and select my Rev 2. And I'm going to go ahead and say OK here. And now it's going to go through and it's going to tell me the difference between these two models. So you can see over here, when I make this one my work, it lets me know what the difference is. And if I say compare information, it tells me what has changed. So this is a nice tool that you can quickly go in and tell the difference between one rev to the next. It also has information over here that lets you know what the source part, comparison part, what the change is. You can create a report if you like. You can do different layouts for the windows. So additionally, it gives you information at last saved date for each one. So this is a great tool for anybody that may be going in and going back and double checking any different revs. So if you're a checker of any type, or if you just need to go in and make sure that the change has been made. So this PMI compare is a very nice tool that makes it a lot easier to redline drawings. Next, we're going to be going into some PMI automation. I'll show you how to define rules. I'll show you how to use the reuse library. And then we'll talk about out-of-the-box MBD rules and how they can be saved. So back in NX here, I have a model, and as you can see, this is a body. And I'm going to go in and actually add PMI to this. I've already created a rule, and I'm going to go insert this rule. And then after I insert it, I'll go ahead and show you how we can create this rule and can be utilized. So up here in the instance, I have all my rules here that I have already created or they're out of the box. In this case, I got an MBD logic rule that I've created, and I've done it for holes. When I go ahead and I select this, you'll go ahead and see that I can create hole dimensions, I can change the deviation of grade, and so on. I'm going to go and apply this, and as soon as I apply this, you notice it goes in and adds the PMI for me. Now I'm going to undo this, and we're going to go together and create this. So we're still in PMI, and this time I'm going to go to define instead of insert. From here, I have several different options that I can do. I can go through all the nodes if I like and go and find what I need. Or if I already know what I want, I can actually do searches on them. For example, if I say create, notice it gives me a list, and I can go in and start getting this information. So let's go ahead and find a create hole. Actually, let's just go ahead and type it in, create hole. You'll see right now, I got a create hole dimension. From here, I'm going to go in and actually place this over here by inserting it. And this is the beginning of our rules. So I'm going to go ahead and continue to create my rules here. I'm going to right click and I'm going to go ahead and say create input. And it's going to go in and find information. Now for this particular one, I actually want to go and delete this because I'm going to go and actually group these holes. And I'm going to go ahead and say group by. And now I have additional one in here that I can go and use. I'm also going to go ahead and create a diant from here to here. We're going to create a path. And then from here to here. So you can see it's pretty quickly done. And once you understand this rules and how to utilize it, you can set these rules for your whole company and your designers, draftsmen, or whoever can utilize these to actually go in and quickly create information. Let's continue and fill this rest of these out and put the rest of these boxes, and then I will show you how we can save this and utilize it. So we have our deviation here. I'm going to go and create another input. The deviation, I can tell which deviation I want. Grade, I'm going to create another input. And we get our grade there. And last, I'm going to go and actually put my output here. And from there, now I have my rules saved. You can see once I put the output in that these dimensions are now on the particular part. So let's go ahead and finish this. Actually, let's go ahead and save this. And this time I'm going to go and save it as a new rule. We'll call it hole 2 this time, just so we know the difference. And I could put a description here if I like. I'm going to go ahead and apply that. And we're going to finish. Now you can see it's finished and we have our PMI. If we go over to our resource bar over here, you can look into our PMI MBD navigator and you can see we applied form to datums, hole 2, and you can see the PMI within the part. Now, if you came into a fresh part, you now have the ability to go into insert instance, and you can come down, find your hole 2 logic rule, and apply that. Now, these rules are saved within the C program, and whichever revision you're in, an MBD logic rules. I went and copied my 2007 rules over, and this allows me to reutilize those rules I've had. Now, out of the box, you do have several different rules that you're able to use. You can create datums, you can create, let's see, dimensions, different baselines, convert to basics. So there's a lot of different rules that you can utilize that are already out of the box. So that there will allow you to go in and have your users be able to use the rules and bring this information over pretty quickly. For the last part of the day's webinar, we're actually going to go in and do some technical data. Here you can see a 3D PDF. We're going to jump back in NX and we're going to create this together. All right, so we're back in NX and I have my PMI block that I created. And within our PMI tab, we have this area for technical data. We're able to publish it here. These are out of the box, but you can go in and create your own under new template. For today, I'm not going to get into that. We do have another webinar and video that shows that. But for today, I just want to go in and show how we're able to create these 3D PDFs and how quick and easy it is. So here you have your different ones that are out of the box. And I'm going to go ahead and I'm going to pick one of these. Let's go with the landscape one. Let's go with the part landscape. So here you have your selected views, all disclosed views, all views. Let's go ahead and say selected views. I'll come over and pick my views that I want. From there, I have my area where to save this. I'm going to leave it where it's at right now because it's going to go in the area I want it to be. And then we have up here new additional tabs up here. You have your text, so you can put some text in there. And we'll go ahead and put some information. And then we'll go ahead and apply this. Now, I'll go in and open up my PDF, and now you can see we have ourselves a 3D PDF. I can rotate this part. I can switch to different views. I can put comments in here. And now we can send this off to an individual that may not have NX or have a CAD program, and they can go in and utilize this information. So now we went through all these steps. We talked about what is model-based definition. We went in and did some PMI, product manufacturing information. We did a PMI validation. I showed how to do PMI search and reporting. We did some automation. And then we went in and did some authoring here with our 3D PDF. So that wraps up today's webinar. And if you have any questions or comments, please, I'll open up the floor now. And you can always email me at bryanfisher@prolim.com. And please go and like and share our YouTube channel. Thanks again for attending.
My name is Keith Schultz, and I'm going to be covering a little bit about NXCAM, their new probing interface. Let me get my screen shared here. All right, so NXCAM has a new on-machine probing module, and we're going to be talking about that this morning. This is going to be an overview of use, and we're also going to be look at getting some additional features to download in an NX from PostHub, such as the simulation and the post-support layers. So this is what we're going to talk about. We're going to look at the Siemens Cinemeric side of things. So on the Fanuc side, there's more features, and we decided to give that its own showcase later. So this is going to be a brief informational presentation to let you see the new interface, and we encourage you to download it and play with it yourself. All right, so what is OMP4? So most of us have probably heard the term probing, and most machine tool manufacturers have provisions for probing. And automated tool setting is the standard for setting our tool offsets. So while NX is not new to probing operations, this new module will help you streamline your programming workflow. So no longer do we need to generate each move separately. So OMP is exactly what it sounds like. It's measuring a feature while it's on the machine tool. So why use it? Why use OMP? So if you want to digitally expand your machine shop, you can become more effective, efficient, and profitable. A digital shop provides powerful advantages, including reduce our turnaround time. We can deliver high quality parts on time by predicting and eliminating errors by using a digital twin of your part. And we can expand and grow our business by implementing new automation technologies. So probing critical dimensions in our workpiece can reduce our scrap rate by allowing us to measure and adjust processes while the workpiece is still in the machine. So what does a digitalized workflow for our part look like? So it might look like this. We can probe our tool to check for breakage and update our wear. We can then probe our stock to check for errors in setup, operated or robot tended. And we can make fine adjustments to our works offsets that we can use logic if it's off enough to throw our operator in error and get that some special attention, right? So after machining, we can probe critical dimensions and adjust our process and have an automated rework process, or we can write logic to an alert operator again. But in the long run, we can also capture this data and follow the trends for tool life. We can use that to keep our process under predictable control. So instead of switching to a backup tool once we detect breakage, we can determine that, after so many parts, we probably should switch to our backup tool. So let's talk about robot tended CNC machines, right? So a crucial part of a robot tended machine cell is going to be probing. So why? So if we want to be able to run a lights out process, we need to ensure our part is correctly loaded. So being able to check that the robot and machine work together to load that part correctly can save us costly errors and some pretty grisly non-wanted results. So what are the probing cycles first? So the OMP solution, it offers the possibility of certain measuring operations before, during, and after a machining operation. So this provides functionality to pre-program the control measurement cycles in our digital twin. Going out to your machine and hitting buttons isn't going to save you any time, right? And we can verify that these same tool paths on our digital twin in real time and react to those measurement results. So a cycle is generated by the post processor that executes measurement macro available on the machine tool. So these cycles are machine tool specific to the manufacturer. So what can you measure? So if the probe can get to it, we can measure it. So there's a lot of options here. You can see some of these small thumbnail images. There's options for measuring pockets, bosses, ribs, and planar surfaces. We can also measure a linear vector based on 2 pockets, which I thought was pretty cool. And we can also modify these cycles in a user-friendly operation dialog. So how to use on-machine probing cycles. So a whole range of cycles are provided for programming, but unlike what you might expect, you don't have to select the cycle first and then select geometry. And instead, kind of like the toolpaths are that you create now in NX, instead what you do is you select the geometry and then you get a suggestion of which cycle you're supposed to use to measure that geometry. So let's take a look at this module. So I have my part set up here, and I've determined, look at our workpiece. So I'm using the master model process as well. We have our part defined. We have a blank model we brought in defined, and we also have some check geometry. All necessary steps whenever you're setting up an operation. So first thing we want to do if we want to start probing is we need to create a tool. And you see this automatically comes up because I've used it recently. But you can see we have a probe option here. We can also, we can make a tool ourselves, or we can select a tool from our library. And that's those are located in the solid tools in the probes. And you can select between your different library units. And when I say OK to this dialog, you'll see that 2 probes show up, and we can select one of these. Now, if you have to create your probe, you're going to have to give it its mounting location, the length from the mounting location, and you're going to have to identify the tip. All right, so now let's create an operation. I'm going to switch over to my operation view, my program order view, and we're going to start creating an operation. So I already have probing set up, but you can see that's going to show up over here in your type. And I'm going to put that into our probe work offset. This will be one of our first operations we do. My tool is a probe, and our geometry is going to be workpiece. And we're going to use a method here, and this might seem a little different to you. I've created a method, and I'm going to show you real quick how we use these methods in probing. So if I come over here to create method, what you see in here is we can have our tolerances, and we can also put our feeds in here for our probing. So depending on what type of probing you're doing, if you're just locating stock and setting your work offset, you might not need a huge, a very small tolerance. You might need a bigger tolerance. But if you're programming to look at a feature and make sure it's within tolerance, you might want to change these numbers to whatever your tolerance is. So that's how that works. All right, so we have all of our 4 parents populated, and we're going to name this operation our find Z. Very common thing we do first. Select OK, and we see the new dialog box. So this is how the workflow works in this, is we're going to select our geometry. A cycle is going to show up, and then we're going to hit our probing parameters, and that's where we're going to do our changes to our cycle. So for now, I'm going to select this top face of our stock and OK. And here we go. We can see 3 cycles that show up. And if you hover over each one, you'll get a description and a cycle number, which is also over here, of course. There's a single edge. There's aligning a single edge. And there's aligning a surface to a plane. So right now we're just trying to find and set Z. We're going to stay there, and we're going to into our probing parameters. So looking here, we have a whole bunch of locked boxes. Let's unlock some of these and see what we have in here. Set them all to user defined. And the first thing it's property to do is a measurement point. Right now it's going to be the center of part, but I'm going to just move it off the center of a part just so we can see that the tool path has already been created. And we're going to select our offset target, and we're going to put that as our work offset. You see a couple more windows open up, so let's go ahead and unlock those. And we have a few options here, either our active work offset, or this is for cinematic control. And you can see that we have all the available options there for the controller. I'm going to select G54. All right, we're done there. I'm going to select OK and generate the operation. And there you have it. So, and what's the next thing we might want to do is we might want to find the center of this stock in X and Y. So we're going to create another operation. We're going to call it find XY. And everything else is going to be the same. We're going to the program is going to be in our probe work offset subprogram. We're going to be using our probe again, and the workpiece, and we're going to use our probe work offset method. Once again, the same workflow applies. We're going to specify our probing geometry. It's going to be outside of the cylinder, and it'd be the same thing if your stock was a rectangle. You'd select all 4 sides. Select OK, and I'm going to get some options. So we have a spigot, cycle 977, or we have a spigot with just a auto circle segment. We're going to select that first one and look at the parameters. And you'll see the first thing that comes up is this measuring point. And what that is basically how far down on this stock do we want to measure. So I'm going to bring that up a little bit higher. And so let's look at some of these options in here. Once again, we can select our work offset, define our work offset that we're going to use. And let's unlock this right here. And we're going to have this user be defined. So we want to be use our center point offset, right? Once we're done, I'm going to select OK, and we can generate. Now that's all generated. So earlier we talked about using a robot tended cell and how you might need to make sure this part is mounted correctly. So if that part wasn't mounted correctly, you wouldn't want to go and adjust an offset. You might want to put some logic in there that basically stops everything, gets the yellow light blinking and gets an operator over there. So let's see how that works. We're going to use the same kind of thing, and we're going to use we're going to check plane. Remember, you can't use spaces in X. And we'll use all the same settings in our parents. All right, once again, our workflow is to specify our geometry. In this case, it's the face. And we're going to come down to this 3D align plane. And once again, you can hover over it and it's going to tell you what it does. All right, once I have that selected, let me go into probing parameters and see what different things we have here. The first prompt it's going to give you these, it works off of 3 measuring points. You can't get a plane off of just 2 measuring points. So you're going to have to select each one individually. Get that right. There we go. Make sure you have your green check mark as well. There we go. Select OK. And let's look at our probing parameters. So in this case, we have options of works to offset or measuring only. Maybe we wouldn't want the table to tilt and we might want to just measure only. Oh, looks like I have to reselect my points. There we go. And we can generate that. I'll select OK. And while we're here, I want to just show you one more thing, is that we can actually run that simulation in the graphics window. There you go. So let's talk about some of these mill control operations you see up here. Some of these operations will require you to use a mill control operation, but luckily NX has given us some samples that we can just plug into our mill control operations. So if I go to create a mill control operation, and I need to enter some logic, let me click on notes. I can go ahead and grab this, and this came from the probing cycles templates, and you can see we already have some logic up here, right? So let's just put any one of them in here. There we go. And you can see that populates with your Cinemerica machine code. And you could put multiple things in here. You can actually, this is where you could put your logic to actually have the machine stop there and get the operator to come and look at what your robot did. All right. So let's get back into our PowerPoint. So we've done all this. So we saw how this is the NX on-machine probing module currently works, and Siemens is really leaning heavily into Industry 4.0, and they have been for a while. So they're expanding this offering. So this module looks like it will take this new adaptive machining module looks like it will take some more of the work out of our workflow and take care of some of the logic operations. I'm not sure, but this text here that you're looking at came directly off the Siemens site. So we're really excited to see what they're going to come up with there. So this is going to be a huge benefit for your digital manufacturing process. So if you currently don't update your NX version, you might want to consider upgrading when this module comes out. And of course, we will post another video about it when it is established. So setting it up. So there's a few things we need to do to get this run correctly in NX. And so updating cycles. So the out of the box on-machine probing control cycles released in 2306 and later are under maintenance. So they're continuously updating. I think new updates are dropping all the time. So therefore, possibly it's been created to download this content via Siemens NXCAM Post Hub. So for your post processor, you need to download the on-machine probing post layer. So in order to obtain a machine cycle via the post processor, it is necessary to extend the custom post processor. For this purpose, you go on Post Hub, and you can add this layer in your post configurator. The example provided is on the basis of a non-tailored post processor, and it may be necessary to make adjustments. So always check for your correct outputs. So if you want to use machine simulation, there's also the CSE, simplified probing routines. So in order to be able to simulate any machine cycle via the machine simulation, it's necessary to extend your existing CSE simulation. There's also an example of that on Post Hub. So included the required subroutines. So in order to verify the desired simulation in the machine cycle, the example is provided on the basis of a non-tailored simulation. So once again, you want to check those before you run on your machine. So how do we get all this free stuff? Obviously, we got to go to Post Hub. If you haven't from NX gotten to Post Hub before, you can just type in into your search bar at the top left of your, top right of your NX screen. So you're going to need your Siemens sign-on from your org, or if this is your own personal NX, you enter your data in there. All right, so once you download and unzip these files, you can open up the folder structure, and you're going to find this great tool in there, this folder called documentation. So you're going to have a handy little instruction document in PDF to help you guide you through the installation process. And there's also another way to get the expanded cycle package installed. So there's a script that comes along with that unzipped file. And it's called on machine probing installation.bat file. So we can also manually move these expanded features. But if you're going to use this installation.bat script, a special note is if you have a space in your file path like I do, so like C / program space files, it's not going to work for you. I even tried, putting some parentheses in it. It didn't work very well. But what it has you do is take a log file and drop it into the folder where that installation script is, and it looks for where your probing is located, and it's going to drop those files in for you. If you can use it, it's going to save you a little time. All right. So I hope you enjoyed this taste of the new probing interface, and we hope you get a chance to download it and experience yourself. And if you're part of an organization that's currently like on NX 11 or really far behind on their version of NX, hopefully you convince them to upgrade, especially with the new adaptive machining module coming out from Siemens. So expect to see more from us on probing in the future. And for now, we're going to take, after we get some questions, and I want to know if anybody has any questions.
Good morning, everyone. This is Ashwini Patil. I lead the Mendix IoT and Cloud Solutions at Prolim. So today we will be taking a look at Prolim's Mendix competency and some of the demos of the solution that we've developed. Here's a quick intro about myself. 25 plus years of experience in technology, management, delivery, and architecture. Prior to Prolim, I worked at Optum, which is United Health Group's IT division, and I have a long tenure in the automotive industry as well. I worked at IHS Automotive. Here's a quick look at the agenda for today. First, I will be talking about Prolim's Mendix competency. Then we will take a look at one of the use cases where we used Mendix and integrated with the NX and Teamcenter. And finally, there's a demo of a few solutions we've developed for customers, which range across different industries. So our Mendix competency is driven by Prolim Digital Innovation Center. Our Digital Innovation Center consists of 3 pillars: PLM Factory, Cloud Factory, and Mendix Factory. Our Digital Innovation Center is very successful because of its underlying framework. The framework, which consists of innovation, agile development, fast delivery, and strong project management. We started our Mendix journey back in October 2020, and today we have a large team, a large certified team of project managers, solution architects, senior developers, business analysts, and a dedicated quality assurance team. And our goal is to have a 100+ member team by the end of this year. Our Mendix team has developed multiple applications serving different industries. We have been recognized as Mendix Magnificent Partner. We are also an ISV partner, which means we can sell our Mendix applications on Mendix Marketplace. Our goal, again, is to develop 200+ apps by the end of this year. So we are over 150 applications today, all different types of applications across various industries. So moving on, next we will take a look at the use case where we developed a Mendix solution and integrated it with Teamcenter and NX. So this solution is called Design Validation Automation. The main goal of this solution is to automate the validation process of wire harness design using Mendix. So Mendix is the center of this application. We have Teamcenter, which is used as the data source in this application. We used a third-party visualization tool called Vertex, which helps you visualize the 3D images. And we also integrate it with NX to do certain analysis on the data. So here's a quick demo of the application itself.
Design Validation Automation. Here is the application architecture, user flow, and high-level scope of Design Validation Automation. Login with username and password. Navigate to Setting Teamcenter Configurations. Click on Login to Teamcenter. This will take you to the login page of Teamcenter within. On the home page, click on the Teamcenter icon and it will start listing all the items present. Search for the item Vertex. Select on Door Panel and click on Render. This will now fetch the door panel assembly from Teamcenter and push it to Vertex for visualization. Then select the top panel of the door and the top panel clip and click on the camera icon for the snapshot. In Vertex, snapshot is not just a screen grab, but it actually gives a reduced BOM and JT format. Click on Home and on the listing below click on View Snapshots. You can click on the top panel clip for item and render to look at the snapshot taken. Go back and now click on Analyze. On click of Analyze, the reduced BOM assemblies are sent to NX for analysis of the clip and the panel hole dimensions. The dimensions are returned back to the Mendix application, and based on the rule engine present in Mendix, clip and hole validation is done. Then results of pass and fail are populated, which can be viewed by clicking on View Results for each reduced assembly. Earlier, for this kind of small door panel validation used to take about 2 hours at least. In this POC, it takes about 12 minutes overall.
All right, that was a quick look at the demo of our design validation application. Now moving on to a demo of a few other solutions that we developed for various customers. So these are all the applications that are published on our website. We have a Mendix App Store. So if you go to prolim.com/mendix/apps, you will see all the solutions listed there. And you click on Learn More to read more about the solution. And also we have a video associated with all of these solutions on our website. So today we will look at a demo of these applications listed here. The first one would be the 3D viewer. So this is a lightweight 3D viewer that was built using Mendix, which can be used to store and view JT files. Vehicle management system. So this solution is integrated with SAP, MES, and few others. So it's a suite of multiple Mendix applications that track the entire life cycle of a vehicle from production all the way into dealership. This also includes a parts tracker application, which has the ability to scan and track the various parts of a vehicle. Supplier inventory management solution allows you to maintain and track suppliers, plants, and parts at the various plants. Approval management system can be used by any organization for any kind of approval process for their organization. It could be any approval such as reimbursements or any logic design approvals. So this is a very generic approval system that can be very easily customized for any of your approval system across the organization. It's a workflow-based approval management system with email integration and a lot of good features. Finally, we'll take a look at the configure price quote solution, which is a solution that was developed for salesperson. So when a salesperson is visiting the customer on site, he can quickly get gather the requirements from the customer and generate accurate proposal very quickly, right then and there. And this, again, was implemented for two different use cases. One is commercial refrigeration systems, and the second one is for the windows and doors. But again, this can be customized to any of the other requirements. So let's take a quick look at the 3D viewer application. The 3D viewer application is a lightweight visualizer that lets the end user upload, store, operate, and visualize the 3D JT files and 2D drawing files. The user can open the model and rotate, pan, and zoom the model to see the details. The section view provides a view from various angles. User can see the hierarchical tree view of the items that form a model. Toggling the tree node allows the end user to control which model parts are loaded into the viewer. The user can delete, add, and clear section planes to the model on desired direction axis. Markup feature allows user to create a 2D markup on a model, annotate, draw, or add a comment, and save the annotated screenshot. The toolbar item selection mode provides the ability to select a model, part, edge, face, and body. Okay, so that was a quick demo of our 3D viewer tool, again developed using Mendix. So next we move on to the vehicle management system. As I mentioned, it's a suite of multiple applications that were put together and is a very excellent use case of how easy it is to use Mendix to integrate different systems in your organization. And this solution was implemented for a large EV manufacturer. Let's take a look at the solution we developed to automate and integrate vehicle manufacturing operations. We implemented this solution for a large EV manufacturer. Vehicle Management System, VMS, consists of multiple Mendix applications integrated with non-Mendix applications such as MES, SAP, and few more. The VIN generator application integrates with MES application and generates a unique VIN for every vehicle manufactured. The parts tracker application, which manages the parts to vehicle mapping through a QR code scanner. The QA application is integrated with the parts tracker application to receive the information of the vehicles. And once the QA is completed, it sends the data to the OBL application, which is the outbound logistics application. OBL application is used in assignment of the vehicles based on a rules engine to be transported to different state distribution centers. STC application integrates with SAP for the invoicing and tracking of the vehicles and the inventory. In this solution, we also integrate with two non-Mendix applications to ensure delivery of vehicles to customers, OMS application and last mile delivery application. A quick overview of the vehicle parts tracker application. The parts inventory dashboard, VIN inbound tracker, various entities like material master, VIN master, etc., and the Excel importer. All right, that was the vehicle management system integrated with multiple different external systems. Next, we'll move on to the supplier inventory management system. This one helps you manage suppliers, parts, and plants at various locations. It includes stock inventory management as well. Supplier inventory management system allows the user to manage suppliers, plants, and parts. Approval is required for any change to supplier, plant, or parts. Templates can be used for bulk uploads. This solution integrates with Power BI for the dashboard. Let's take a look at the application. Here are the various entities for supplier, employee, external user, plant, and parts. Let's add a new supplier, assign the plant and part. We can download supplier-specific templates for bulk upload, update the data, and import it back into the system. The approver can approve or reject parts on this dashboard. Here, the user can check and update the stock for parts at different plants. The Power BI dashboard shows various counts, such as counts of parts assigned to suppliers and count of parts by plants. All right, that was a quick look at our supplier management system. Now moving on to our approval management system. As I mentioned, this solution can be used for any approvals across the organization for managing the approvals. Approval management system. This solution can be used for different types of approvals, such as reimbursement or specific types of payments. It allows for up to 7 levels of approval. An email is triggered for every request. The approver can approve, reject, or revert directly from the link in the email. The approver can delegate approval authority to a specific person for specific dates. An automated email reminder is sent on a daily basis for pending approvals. The dashboard shows the pending approvals for each approver. Let's take a quick look at the application. Team approvals is a feature where approval can be sent to a team instead of a specific individual. Let's create a new approval. Add all the details. Attach any documents needed for approval. Select the approvers and submit. Here is the delegation form. Let's take a look at the dashboard, which shows all pending approvals for every approver. You can click on any one to see the details. The dashboard also shows requests created by the specific user. So that was the approval management system. Now moving on to the last demo, which is our CPQ, configure price quote, again used mainly by the salespersons to generate accurate quotes.
CPQ, configure price quote, is a tool used by sales representatives to quickly and accurately generate quotes for specific orders, along with a complete pricing proposal real-time within minutes. This solution is available in various versions, browser, mobile, and tablet, and can be accessed from anywhere. Sales representative will input customized specifications of the product, quantities, and the optional features as input and generate an optimized proposal based on the selected parameters. This solution is developed using Mendix in context of an industrial refrigeration system, but can easily extend to any other products. This form captures customer details such as customer name, location, and delivery date. The second section captures the system details. In the case of refrigeration systems, it captures parameters like ambient temperature, relative humidity, and target load. Additional details are captured in the bottom section, such as compressor manufacturer, voltage frequency, and others. The sales executive can also optimize the current proposal based on the following parameters: cost, lead time, and horsepower. This application integrates with Teamcenter and automates the generation of the proposal that includes the specifications of the finalized requirements, the pricing policies of the components, discounts involved, the 3D images of the components and the product. As you have seen, CPQ by Prolim is a great sales tool to generate accurate pricing proposals real time within minutes.
All right, that was the CPQ application. Thank you all. And if you have any questions, feel free to contact us at info@prolim.com to see how we can help you with your Mendix solutions.